ever feel like you're just drowning in information,
Yeah.
especially trying to keep up in fields like tech or data
Oh,
analysis?
absolutely. It moves so fast. New tools, new articles every single day. It's a
Yep.
lot.
It's overwhelming. And
Right.
that's really why we do the deep dive.
Exactly. We try to be that shortcut for you. We dig through all the stuff, the docs, the discussions, the tutorials, and pull out what you really need to know efficiently.
And today, we're tackling something that comes up constantly, particularly if you're looking at careers in data analysis or similar tech roles. Git and GitHub.
Yeah, crucial tools. So for this dive, we've looked at the official GitHub docs, kind of the foundational stuff about Git itself.
Okay.
Then there's this really interesting Reddit thread discussing whether a GitHub portfolio actually helps data analysts get hired. Lots of different opinions there.
Oh, I bet. Always sparks debate.
And we also glanced at a more advanced Git tutorial, just to get a sense of the deeper capabilities.
Okay, so the mission today, cut through the noise. What are Git and GitHub? How do they actually work? And most importantly, why should you care, especially if you're building a technical career where showing your work really matters?
Let's do it. So, starting right at the beginning, Git. What problem is it fundamentally solving?
Good question.
Well, at its core, Git is a version control system, a VCS. Think of it like a super detailed diary for your projects.
A diary. Okay.
Yeah, its main job is tracking every single change made to your project files over time. So you can always rewind, basically. Go back to an earlier version if you need to.
Oh, like a time machine for your code or your analysis scripts.
Sort of, yeah. But maybe even better because it also tells you who made the change, when they made it, what exactly they changed, and hopefully why they changed it through commit messages.
That why seems pretty important, especially with teams.
Hugely important. Imagine trying to untangle a complex project with multiple people editing things without that history. It'd be chaos.
Nightmare.
So a VCS like Git gives everyone a unified, consistent view of the project. It prevents conflicts, keeps everyone on the same page, and fundamentally, it protects the integrity of your work by logging everything.
Okay, now I've heard centralized and distributed version control thrown around. What's the difference there, and where does Git fit in?
Right. So older systems were often centralized. Everyone connects to one main server to get the code and save their changes.
Okay, makes sense.
Git, though, is distributed, a DVCS. And this is a really key difference.
How so?
With Git, every single person working on the project has a full, complete copy of the entire project and its entire history right on their own computer.
The whole history, locally.
The whole history, locally. You don't need a constant connection to a central server to see past versions or even make your own commits.
Wow, okay, that sounds like a massive plus for working offline. Or, if your internet's flaky.
Exactly. Huge advantage. You can commit changes, browse the history, figure out why something was done, all on your laptop on a plane, for example. And that local history gives you all the context you need to understand how the project got to where it is now. Plus, it's inherently redundant. If the main server dies, well, everyone has a full backup.
Okay, I see the power. So how does this distributed nature and Git generally help with collaboration, especially when teams are spread out everywhere?
Because everyone has that full local copy, collaboration can happen asynchronously. People in different time zones can work effectively. And Git uses something called branches. Think of them as parallel universes for your project.
Parallel universes. Okay, I like that.
Yeah. You can create a branch to try out a new feature or fix a bug without messing up the main stable version of the project.
Ah, so it's like a safe sandbox.
Precisely. You do your work on the branch, test it, and when it's ready and reviewed, you can merge those changes back into the main project line. It prevents disruption.
That sounds incredibly useful. Avoids breaking everything while you experiment.
Totally. And organizations can use this branching and merging model to coordinate work across different teams, breaking down silos. Everyone can contribute their part in a structured way.
Okay, so Git is the local history keeper, the collaboration facilitator. Now, what about these repositories people always talk about? What is a repository exactly?
Good point. A repository, or repo for short, is basically the Git project. It's the collection of all your project's files and folders, plus that entire revision history we've been discussing.
Gotcha. The whole package.
Right. And that history is stored as a series of commits. Each commit is like a snapshot of your project at a specific moment in time.
Like hitting save as, but with more context.
Yeah, it's a decent analogy. A save state with a description of what changed and who did it. And these commits form that history, often including those branches we mentioned.
Okay.
And again, because Git is distributed, These repos are self-contained units. If you have a copy of the repo, you have everything, the code, the history. No need to constantly ping a central server for the backstory.
So once you have a repo, what are the main things you actually do with it?
Oh, lots. You can browse the history, obviously, jump back to see the code at any point in time.
Mm.
You clone a repository to get your own local working copy. You create branches, switch between them using checkout.
Right, the branches.
You make your changes. Then you add the files you want to save, and then you commit them to record that snapshot. You can merge different branches together, compare versions. It's quite powerful.
Okay, now let's bring in the other half of the equation, GitHub. Is GitHub just a website where you stick your Git repositories?
That's the starting point, yeah.
Yeah.
It hosts Git repos online,
Yeah.
but it's much more than just storage.
Okay, how so?
GitHub adds a whole layer of tools and features on top of Git, specifically designed to make collaboration and software development smoother.
Like what kind of tools?
Well, a big one is the web interface itself, which makes visualizing history and changes much easier than just the command line for many people. Then you have issues.
Issues, like problems.
Yeah, but also for tracking tasks, feature ideas, discussions about the project. It's like a built-in project management and discussion forum for each repo.
Ah, okay. More than just bugs.
Definitely. And then there are pull requests, or PRs. These are fundamental to collaboration on GitHub.
Pull requests. Heard that term a lot.
So you make your changes on a branch, right?
Mm.
A pull request is basically you saying, hey, I've finished this work on my branch. Could you review it and consider merging it into the main project?
So it's a formal request to incorporate your changes.
Exactly. And it opens up a space for discussion, automated checks, code review by teammates before the changes actually get merged. Super important for quality control.
Makes sense. What else does GitHub offer?
There's a marketplace for apps that integrate with your workflow, things for continuous integration, code analysis, and importantly, it's a huge community, millions of developers.
Right, the social aspect. So it's about connecting with others too.
Absolutely. GitHub really builds collaboration into the process. Repos become these central hubs. You can outline requirements in the readme or wiki, track tasks and issues, and then use the typical GitHub flow.
The GitHub flow.
Yeah, the common pattern. Create a branch for your work. Make your commits on that branch. Open a pull request to discuss. Get it reviewed and approved. Then merge it. Branch, commit, pull request, merge.
Branch, commit, pull request, merge. Okay, got it. So how do you actually use Git and GitHub day to day? Is it all command line stuff?
Primarily, yes. You interact with Git using commands typed into your terminal or command prompt, like git commit, git push, git pull.
Right.
But there are also graphical tools, GUIs. GitHub Desktop is a popular one.
Yeah.
Gives you a visual way to do many common Git operations, which some people prefer. The command line is generally more powerful, though.
Can you maybe list a few absolutely essential Git commands, ones you really can't live without?
Sure. Git init that starts a new repository in a folder.
Okay, initialize.
Git clone that copies an existing repository, usually from GitHub, down to your computer.
Makes sense. Clone it.
Git branch lets you manage branches. Create them, list them.
Branches.
Git checkout switches you between different branches or versions.
Move around.
Git add, this one's important. It stages your changes, basically saying, okay, include these specific changes in the next commit.
Stage them. Got it.
Git commit that saves the stage changes as a snapshot in the history,
Yeah.
along with your descriptive message.
The actual save point.
Exactly. Git pull fetches changes from the remote repository, like GitHub, and merges them into your local branch. Keeps you updated.
Pull down updates.
And Git push sends your local committed changes up to the remote repository on GitHub. Shares your work.
Push it up. Okay, those seem like the core actions. The GitHub docs had some examples. Can we walk through one, maybe contributing to an existing project?
Yeah, definitely. So first step, you'd find the project on GitHub and use git clone with its URL to download it.
Okay, clone it locally.
Then, best practice is to create a new branch just for your changes. So git branch my cool feature, and then you check out my cool feature to switch to it.
Got it. New branch for my work.
Then you actually, write your code, make your edits. When you're ready, you stage the files you changed using git add file 1.py, file 2.txt.
Add the specific files.
Then you commit them. Git commit natch m, add my cool feature doing X and Y. The M is for the message. Make it meaningful.
Right, good message.
Finally, you push your new branch up to GitHub. Git push setup stream origin my cool feature. That shares your branch and commits. The setup stream part links your local branch to the remote one.
Okay, that workflow makes sense. Clone, branch, checkout, change, add, commit, push. What about starting a totally new project?
Right, so you'd make a new folder on your computer, CD into it in your terminal, then type git in it.
Initialize the repo locally.
Exactly. Then maybe create a readme.md file, touch readme.md, stage it with git add readme.md, and make your first commit, git commit initial commit. For save point, yep. Now, to get it on GitHub, you first go to github.com, create a new empty repository there. Don't add a readme or license file on GitHub yet if you've already made your first commit locally. That's a key tip from the docs to avoid conflicts.
Ah, okay. Create it empty on GitHub.
Right. GitHub will give you a URL for your new repo. Back in your terminal, you connect your local repo to the remote one using git remote add origin, your GitHub reportal.
Link them up. Origin is like the nickname for the remote.
Exactly. Origin is the standard nickname. Then you push your local commit up, git push u origin main, or whatever your main branch is called. The Birdo sets up the tracking connection for the future.
Got it. Init locally, commit, create, empty on GitHub, link with remote add, then push.
Okay. And one more quick one. Contributing to an existing branch someone else is working on.
Sure, let's say you've already cloned the project. First, make sure you have the latest changes, so CD into the project folder, then maybe get checkout main to switch to the main branch, and then get pull origin main to pull down any updates.
Get the latest stuff first.
Yeah.
Good idea. Then, switch to the feature branch you want to contribute to. Git check out the feature branch. Make your changes. Git add your file. Git commit made some tweaks. Then git push origin to the feature branch.
Okay. Pull, checkout, change, add, commit, push to that specific branch. These flows really help solidify it. Now, the docs mention different ways teams collaborate on GitHub.
Yeah, two main models, basically. The shared repository model.
Share repo.
Right. One central repository, and team members get direct permissions, like write access to push directly to it. Works well for smaller, trusted teams.
Okay. Everyone works on the same main repo.
The other model, very common for open source, is fork and pull.
Fork and pull.
Yeah. If you want to contribute, you first create a personal copy of the main repository under your own GitHub account. That's called a fork.
Like making your own duplicate version.
Exactly. You have full control over your fork. You make your changes there on your branches. Then, when you're ready, you submit a pull request from your fork back to the original repository.
Ah, so you're proposing your changes from your copy.
Precisely. The original project maintainers can then review your proposed changes, discuss them, and decide if they want to merge them to their main project. It's a great way to manage contributions from potentially anyone without giving them direct write access to the main codebase.
Fork and pull. That makes a lot of sense for open source or larger collaborations. Okay, we've covered a lot on both. It's easy to see why Git and GitHub get mixed up. Let's nail this down. What is the fundamental difference?
Super common confusion. Okay, bottom line, Git is the tool. It's the free, open source version control software you install and run on your computer.
Git, software tool, local.
Right. GitHub is the service. It's a commercial cloud-based platform that hosts Git repositories and adds a ton of collaboration features on top.
GitHub, online service, hosting plus collaboration.
Exactly. Think of Git like maybe the engine itself. It does the core work of tracking versions. GitHub is like the whole car factory, the road network, the garages, the driver community, everything built around that engine to make it useful and collaborative on a large scale.
That's a great analogy. The Simply Learn article had a good breakdown, too. Maybe highlight a couple of key differences from their list.
Sure. So again, Git is software. GitHub is a service. Git's maintained by Linux Foundation, GitHub by Microsoft since 2018.
Right, the acquisition.
Git is primarily command line driven. GitHub has a major web GUI. Git is local first, works offline. GitHub is cloud-based, needs internet for most interactions with the remote
But
stuff.
local versus cloud, key difference.
Git's job is managing source code history. GitHub's job is hosting those histories and facilitating teamwork around them. Git itself doesn't manage users. GitHub has robust user management and permissions. Different launch dates, Git 05, GitHub 08. Different licensing, Git is open source, GPL. GitHub has free and paid tiers. Even their desktop tools are different. Git GUI versus GitHub Desktop.
That really clarifies things. So GitHub basically takes Git's power and makes it easier to share, manage, and work together on projects.
That's a perfect summary. It enhances Git, makes it more accessible.
Yeah.
And remember, you can absolutely use Git without GitHub. Just manage your versions locally.
Right.
But GitHub needs Git. Git is the foundation it's built on.
And GitHub adds those extra layers, project management, bug tracking, wikis, all that stuff.
Exactly. And the public nature of many GitHub repos leads to that social coding idea, learning from others, contributing back. It's a huge ecosystem.
Okay, let's pivot. This is a big one for listeners, especially in data analysis. Does having a GitHub portfolio actually help you get hired? That Reddit thread had some strong opinions.
It really did. The overall vibe.
Hmm.
If you don't have a ton of on-the-job experience, then yes, a good GitHub portfolio can be super valuable.
How so?
It lets you show, not just tell, show you can solve problems, work with data, write code,
Hmm.
things beyond just a degree or a bullet point on a resume.
So it's proof of practical skills.
Exactly. Now, the thread suggested it might not be the thing that gets you the interview initially.
Oh, why not?
Well, some mentioned that recruiters at big companies, dealing with tons of applications, might just scan resumes for keywords first. They might not click every GitHub link right away.
Ah, the volume problem. Makes
Yeah.
sense.
But where it really seems to shine, according to many commenters, is later in the process, during the technical interviews, talking to the hiring manager or the team.
Okay, so it helps you during the interview.
Yeah, significantly. It gives you specific projects to discuss. You can walk them through your thought process, the code, the challenges. It makes your skills much more tangible.
But the quality of the projects matters, right? Can't just be random scripts.
Oh, absolutely critical. People on Reddit stress this. Your projects need to be relevant to the jobs you want. Tackle realistic problems, not just, the iris data set again.
Haha. Yeah, seen that one a few times.
Right. Vague descriptions like sales analysis dashboard, don't cut it. Show the whole process. Problem, data, cleaning, analysis, code, insights. Tell a story with each project.
So thoughtful, relevant, well-documented projects are key. Not just having a portfolio, but having a good one.
Precisely. And even just having the GitHub link on your resume can make you stand out a bit.
Yeah.
Shows you're engaged, contributing to open source. Even better, shows collaboration.
Interesting point, though. Someone on the thread said their hiring committee didn't find portfolios useful, saw them as maybe a sign of inexperience, and valued networking more.
Yeah, that was an important counterpoint. It shows it's not universally valued the same way everywhere. Company culture, role seniority, individual manager preference, it all plays a role. And for really entry-level spots, sometimes deep subject knowledge might trump a portfolio. But even then, having projects to talk about can seriously boost your confidence in interviews.
True. So what was the practical advice from the thread on building a good portfolio?
Focus on relevance, tailor projects to the jobs you're applying for. Use keywords in your project descriptions and resume. Aim for quality over quantity, maybe 3 to 5 solid end-to-end projects.
Quality, not just quantity. Got it.
Document your code well. Make it understandable.
Yeah.
Consider contributing to open source. Use platforms like Kaggle for ideas and data. And crucially, be ready to talk about your projects in depth. Explain your choices, the code, the outcome.
That's solid advice. Be prepared to back it up. Okay, shifting slightly. That advanced Git tutorial hinted at more complex stuff. What were some highlights? Just a glimpse.
Yeah, it showed Git has a lot more depth. Like the detached head state, letting you check out commits directly, kind of like read-only mode for the past, for experiments.
Interesting.
Creating and applying patches, basically files containing code changes, useful in some workflows. Cherry picking, grabbing specific commits from one branch and applying them to another.
Cherry picking sounds useful.
Very. Git stash, temporarily saving your uncommitted work so you can quickly switch to fix an urgent bug on another branch, then come back. Lifesaver sometimes.
Oh, I can see that being handy.
Git bisect, an amazing tool for finding exactly which commit introduced a bug by doing a binary search through your history.
Wow, like a debugging superpower.
Pretty much. And then there's rewriting history using git commit amend to fix the last commit message, or git rebase, interactive rebase, to clean up multiple commits before sharing them, like squashing small commits together, reordering them, editing messages.
Be careful with rewriting history, though, right? Especially if others have pulled your code.
Absolutely.
Yeah.
Generally, you only rewrite history that hasn't been shared publicly yet. It also mentioned undoing things with git revert, creates a new commit that undoes changes, or git reset, which can actually remove commits, use with caution.
Okay, lots of power under the hood. Now, what about recruiters? That Kula ATS article talked about how they use GitHub.
Right. It confirmed GitHub is a major hunting ground for technical talent. Recruiters actively search it.
How do they search?
Based on languages used in repos, location in profiles, keywords, contributions to certain projects. They're looking at your public activity as a signal of your skills and interests. There are even specialized tools recruiters use to automate sourcing on GitHub.
So my GitHub profile is basically part of my professional brand, visible to recruiters.
Exactly. A well-maintained profile with relevant projects makes you discoverable. The article did mention challenges for recruiters, the sheer number of profiles, verifying skills. But the takeaway for you, the listener, a good GitHub presence increases your visibility to people actively looking to hire your skills. Simple as that.
Powerful motivation to keep that profile updated. What about resources for learners, students specifically?
Oh yeah, the GitHub Student Developer Pack is amazing. Huge bundle of free stuff for students.
Like what?
Free access to GitHub Copilot, the AI pair programmer.
Whoa, free Copilot. That's big.
Yeah, free domain names, cloud credits on Azure or DigitalOcean, access to tons of other developer tools and learning platforms. It's incredibly valuable if you're eligible.
Nice.
Plus, features like the profile, RayDM lets you create a nice intro page in your profile. And CodeSpace's cloud-based development environments, so you can code right in your browser without complex local setup. Great for getting started quickly.
Fantastic resources for students. Now, GitHub isn't just code, right? Issues and projects.
Correct. GitHub Issues is the built-in tracker within each repo, used for bug reports, feature requests, task lists, general discussion about the project's work. Supports formatting, linking code, assigning people.
So, integrated task management.
Yep. And GitHub Projects is even more flexible. Lets you create Kanban boards, tables, roadmaps to visualize and manage work across multiple issues and pull requests. Customizable fields, progress tracking. It's quite powerful for project planning.
So you can manage the whole life cycle, plan into execution right there.
Pretty much. Keeps the planning close to the code. Very useful for teams.
Okay, last piece. Those best practices from the Magic Box docs. How do effective teams use GitHub well? Any key tips?
They emphasize clarity, meaningful repo names and descriptions, good setup. Initialize with a helpful readme, a proper .gitignore file to keep junk out of the repo, and a clear license.
Start clean. Makes sense.
Organization. Use labels effectively on issues and PRs. Automation. Set up continuous integration CI to automatically test code changes. Use code quality tools.
Automate the checks.
Maintenance. Keep things updated. Issue status, project boards, and crucially, communication. Use pull requests as the primary place for discussing code changes. Encourage code reviews. Talk about the work openly.
Communication is key. Okay, let's tie this all together. What are the absolute main takeaways from this deep dive?
Number 1, Git is the underlying engine, the version control software. GitHub is the powerful platform built on top hosting, collaboration, community, project management. They're different, but work together.
Got it. Get the tool, GitHub the platform. And for technical careers, especially data analysis.
Your GitHub presence matters
Eh.
a lot. A curated portfolio showing relevant, well-documented projects is a massive asset for demonstrating your skills and getting noticed by employers.
It's tangible proof of what you can do.
Exactly. It can really set you apart.
So the advice is clear. If you're in a technical field or aspiring to be, get comfortable with Git and build your GitHub profile. Explore the resources out there, GitHub docs, tutorials, the student pack if you qualify.
Definitely. And maybe a final thought to leave you with. Mastering tools like Git and GitHub isn't just about learning commands. It's about building your professional identity in the tech world. It's about showing your work, collaborating effectively, and becoming part of that larger community. So what story could your GitHub profile start telling?